Now, this chapter is all about acids and bases. Now, you're probably already familiar with a lot of acids and bases from other classes or just from your everyday life. So a lot of this is going to be a review, but hopefully we'll add some new stuff on why we consider them acids and bases and what happens when you mix them together, or how do you measure your acids and bases. Now, this slide has some of those common characteristics of acids and bases that we're familiar with, some physical properties that we can use to tell a difference between them. For example, acids taste sour. Oh, now before you go to the lab, start tasting chemicals. Remember, we never, ever, ever taste chemicals in the lab. Remember the Twinkie from that safety video at the very beginning. But one of the very first things that I gave my oldest child, my daughter, was a lemon. And you guys have all seen what happens when you give a baby a lemon and their face gets all scrunchy and you have that sour taste. Can you actually taste that right now? Can you get that tingling? They taste sour. They're going to turn litmus red. Now, litmus is an example of an acid-base indicator. So down on the bottom of the slide, it says acid-base indicator. This is a dye that changes colors as you change the acidity or basicity, how much of a base that solution is. So litmus changes about at a pH of around 7 to 8. So if it's red, it's an acid, and we're going to learn if it's blue, it's a base. Now, depending on what type of indicator dye you get, they'll change at different pHs, and they also change different colors. Litmus is a very, very common one. Be familiar with litmus. Later in the chapter, we're going to talk about phenolphthalein. That's another good one to be really, really familiar with, but we'll get to that later. And finally, your acids react with metals. So a couple years ago, I had a car battery that exploded. Did you know car batteries can explode? It got battery acid everywhere all over my engine. Well, we had to neutralize that because we didn't want it to react with the metal. Now, the battery acid that's most common is going to be sulfuric acid. So that's another example of an acid. Your bases taste bitter. Again, never ever taste things in the lab. They turn litmus blue and they feel slippery. So what that means is if you get a base on your hand, that base starts reacting with the oils in your hand and it actually starts to form soap. Kind of a cool reaction there. That's how you make soap. You take a base, take a fat or oil, mix them together, voila, you have soap. But you don't really want that on your fingers. So if you're in a lab and you get something on your hand and your hand starts to feel really slippery and it won't wash off, you're probably exposed to a base. Now we can help neutralize that base. You just have to let the lab instructor know. You pour vinegar over it. There's scenes in, let's see, Fight Club has a scene with it, and Justified. There's a lot of different movies where they use that as a punishment. They'll pour sodium hydroxide pellets over someone's hand to make them do something they don't really want to do. And you're like, oh yeah, the little plastic pellets hurt so bad. They're not plastic pellets, it's sodium hydroxide, and it will burn. It will scar. I have some scars actually on my elbow where I was making lye soap one day and I spilled some lye when I was cleaning up on myself. So it happens. Neutralize it with acetic acid, with vinegar, you'll be okay. So here are some common acids that you probably have in your house. There's Lysol, that's your toilet bowl cleaner. That's usually a hydrochloric acid solution. Vinegar is acetic acid. Lemons have citric acid in them. Your aspirin has acetylsalicylic acid. Oh, that one's fun to say. We actually have a chapter about that one later on. And then vitamin C has ascorbic acid in it. Your bases, a lot of those will have sodium hydroxide, like Easy Off, your oven cleaner, or Liquid Plumber, which helps with toilet bowl cleaners. Tums usually has like a calcium carbonate, or you might see a magnesium hydroxide, or Aluminum carbonate's another example you might see in an acid. Ammonia is NH3, that's a base. Baking soda has sodium bicarbonate. And then batteries will have potassium hydroxide or another base. So what happens if an acid is combined with a base? Well, you always get two products. If you take an acid plus a base, you'll end up with salt and water. Well, water you're familiar with is just H2O, but salt in this case does not mean table salt. It does not necessarily mean sodium chloride, although sodium chloride is an example of salt. Salt is a compound other than water produced by the reaction of an acid and base. It's kind of a generic definition. I like the definition below that a little better. It's an ionic compound. So what we mean by ionic is that we have a metal plus a nonmetal. I can't spell nonmetal. Let's see if I can do better. Nonmetal. There we go. So for instance, sodium chloride, we have a metal plus a nonmetal. That is an example. And they won't contain hydroxide. That OH negative is hydroxide. That's only found in bases. So this slide has 4 examples of neutralization reactions. Acid plus base goes to salt plus water. So first look at the acids, the first substance written down for each reaction. Notice that each of those acids have a hydrogen that's available to react. Now the first one actually has a typo on it. It says hydrochloric iodide. That doesn't make sense. It should be hydroiodic acid or a hydrogen iodide. So they had a little typo in the picture. We have sulfuric acid and acetic acid. Now acetic acid, sometimes they write that hydrogen at the end. Other ways to write that particular compound put the hydrogen at the beginning. This tends to be a weak acid, so sometimes it's written just a little bit different. If you look at the bases, hydroxide is a very common base. So we have potassium hydroxide, magnesium hydroxide. This is bicarbonate and this is carbonate. And whenever they react, they form salt. So if you notice, all of them are ionic, metal, 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 and then it has a non-metal, non-metal. That's a non-metal. That's a great big non-metal. Those are called polyatomic ions. And then they produce water. And some of them also have carbon dioxide as another product that could be formed. Now, here in Southeast Kansas, we tend to have very, very hard water, meaning that we have a lot of ions in our water, such as calcium, magnesium, and iron. Now, that calcium can cause hard water stains or hard water deposits to form. And occasionally your faucets will get like this white buildup on them. What we can do with that buildup is called calcium carbonate, CaCO3. We can actually help get rid of that by soaking that faucet head, or in this case the shower head, in a solution of vinegar. Vinegar is a weak acid. It'll react with that base. It'll form calcium acetate, which is just a soluble salt, water, and then carbon dioxide. It'll produce actual gas bubbles. So that's one thing you can do if you do have some problems with a faucet. Take a baggie, pour some vinegar in it, put it up over the shower head, secure it with a rubber band, and leave it for a few hours and see if that helps. So I had to throw in a quick little question. Which one contains an acid? Easy Off oven cleaner, Tums, a stomach antacid, Lysol salt toilet bowl cleaner, or alkaline batteries? Which one could it be? Well, your acid is the Lysol, the toilet bowl cleaner. It usually will have hydrochloric acid in it.